Okay, so here's a studying for the Chapter 12 test. It says a dime is tossed and a card is selected from a deck of 8 cards labeled 1 through 8. So you flip a coin, and there's two options, either heads or tails. I'm making a tree diagram here, as you can see. And if I get heads, then there's 8 options here. I can get a 1, 2, 3, 4, 5, 6, 7, or 8. 3, 4, 5, 6, 7, and 8. 1, 2, 3, 4, 5, 6, 7, 8. And the same exact thing for if I get a tails. That is one of the correct tree diagrams. So the number of outcomes from a tree diagram. Here's how I figure out the number of outcomes. Well, there's 8 options when you get heads, right? And 8 options when you get tails. That's 16. Another way to figure it out, there's 2 options when you flip a coin times 8 options when you get 1 through 8. So that's 16. Same way to do the same thing. Or a different way to do the same thing. Also, probability of getting tails and a 7. Here's tails. Here's a 7. There's just one way to get that out of the 16 total ways. That's your answer. That's your probability. Also, probability of getting heads and an even numbered card. Heads. Here's heads. An even number, there's a 2, a 4, a 6, or an 8. So there's 4 options out of the 16. So let's reduce it to 1/4. What's the probability of getting heads and not a 1? All right. So heads and not a 1, so that'd be a 2, a 3, a 4, a 5, 6, 7, and 8. That's 7 different options out of the 16 total, which would be, well, just 7/16ths. Moving on. Number 6 here. Isabel has a choice of 6 colors of pants, 2 colors of shirts, 5 kinds of shoes. How many different outfits can she wear? Okay. How many different outfits can she wear? She's got 6 pants, 2 shirts, 5 shoes. Now we could make a tree diagram for this if you really want to. 6 pairs of pants. Red, blue, green, yellow, white, and maroon. Okay? And then from each of these, 2 kinds of shirts. Lots of lines there. And then 5 kinds of shoes. Lots of lines. I'm not even going to look how messy that is already. That's probably because I'm not really trying. Well, the easiest way is to say, okay, 6 times 2 times 5 will get us, you can use a calculator, 60. There's 60 different outfits she can wear. What's the probability of rolling 2 number cubes, that means 2 die, and getting a sum of 9? That's what this says here, a sum of 9. Well, if you either make or remember or look up at the board, 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. Remember, 1 and 1 make a 2, and a 3, 4. You guys remember doing this? Okay. There's 36 total options when you roll 2 die, right? How many of them were 9? There's 4 of them. There's 4 and 5, 5 and 4, 6 and 3, and 3 and 6. You can see them in the table. They're somewhere around here. So that's 4 out of 36, which we should reduce to 1/9. What's the probability of tossing 5 coins and getting ahead on all 5 tosses, which hopefully you know would be really rare. Well, I'm going to toss 5 coins. So that's 5 different probabilities I'm getting. So I'm going to times them all together. Probability of getting heads the first time is just 1 out of 2. Probability of getting heads the second time is, well, 1 out of 2 again. The third coin, 1 out of 2, or the third flip. 1 out of 2 again for the fourth flip, and 1 out of 2 for the fifth flip. So each flip has a 50% chance of getting heads. Multiply all these things together, we get 1 out of 32, which is a really small chance. You should know that, hey, getting heads a bunch of times in a row rarely happens. 9, the number cube was rolled 60 times. 1 was rolled 10 times, 2 was rolled 18 times, 3 was rolled 6 times, 4 was rolled 9 times, 5 was rolled 8 times. So all this information is pretty important. 60 times total, 10 times for a 1, 18 times for a 2, 3 for a 6, 4 for 9, 5 was 8 times, and 6 was rolled 9 times. Experimental probability of rolling a 6. So rolling a 6 is the only thing we care about here. A 6 was rolled 9 times. 9 times out of the 60 total times that these were rolled. reduce this, 3 out of 20. Number 10, at the annual Science Club Festival, 12 of the first 90, there's 90 total participated in throwing a baseball through a tire game, won first prize, 22 won second prize, and 32 won third prize. What's the experimental probability of winning any of the 3 prizes? So first place, there was 12 first place people, and there was 22 second placers, and 32 third placers. That's a total of 66. So 66 out of 90 people won some prize. Reduce them, 22 out of 30, and this will be 11 out of 15. So 11 out of every 15 people won a prize at that science fair. 11. One bag contains 5 blue chips and 2 green chips. Another bag contains 9 blue chips and 4 green chips. A chip was dropped in each bag. What's the probability that both chips are green? So, we're picking a thing from each bag. Bag 1 and bag 2. Bag 1 says probably both chips are green. Bag 1 has 2 green chips out of 2 and 5 is 7. Another bag contains 4 green chips out of 4 and 9 is 13, so 4 green out of 13. Multiply these together, 8 out of 70 is 91. And that can't be reduced, 8 out of 91. That's the probability that both chips are green. 12, a bowl contains 5 red balls and 3 blue balls. One is drawn at random and not replaced. A second ball is then drawn. What's the probability of the first ball? Again, we've got 2 things that are happening. So we're going to take 2 probabilities and multiply them together. What's the probability that the first ball is blue? The second ball is red. The first ball being blue is 3 out of 8 because there's 8 total balls. And it's not replaced, it says. Not replaced. That's important. So it's only going to be 7 balls in there. The red one, there are 5 reds still in there. So this becomes 15 out of 56, and that is all the way reduced as it turns out. 15 out of 56 chance that you'll get a blue and then red. And this is supposed to go with this stuff. Just got cut off, oh well. Tossing 3 coins 100 times. So these add up to 100, just so you know. This 100 is good to know, because then it's going to be your denominator. What's a relative frequency? Again, on your test, I put experimental probability of tossing 3 heads. Well, here's 3 heads that happen 25 times out of 100. Oh, that's 1/4 if you reduce it. 14. In a survey of 120 kids at Harding Middle School, 75 students like to take music as their elective class, and 45 like to take art as their elective class. If there are 500 kids in middle school, how many would you expect to take art? So it asks, see, all right, talking about art, 45 like to take art. So 45 out of the 120, right there, take art. And we're trying to figure out if there are 500 kids, how many would take art? Here we just cross multiply and solve. We just go to our calculator, that's kind of some big numbers. How many is there? And we say, okay, I'm going to do 45 times 500 and then divide by 120. 45 times 500 and then divide by 120. 187.5. Now, can you have 187.5 kids? Nope, can't have a 0.5 part.
That would be a lot.
So 187 or 188 will be fine. Note that if it was a 0.4, you have to round down to 187. Or a 0.6, you have to round up to 188. 15. Main Street Deli is making sandwiches with the following choices: white bread, rye bread, bologna, turkey, ham, roast beef, blah, blah, blah. Lots of stuff, lots of words. For me, I like to write stuff down. So I'm going to show you how. So I like to write, we have bread choices. There's 2. There's white or rye. 3. White, wheat, or rye. There's some meat choices: bologna, ham, roast beef. And then there's the condiment or the spread, mayo or mustard. So there's 3 of those, 3 of those, and 2 of those. Suppose the deli pre-makes one of every possible type of sandwich combination. So 1 item from each category, 1 bread, 1 meat, 1 condiment. To have on hand prior to the lunch hour. What's the probability of a sandwich having both rye bread and ham? All right, since we need probability, we need to find how many total options there are. So 3 times 3 times 2, that gets us 18. So there's 18 total options. So our probability will be something out of 18. And for the rye bread, if it has rye bread and ham, goes rye and ham, it could have either mustard or mayonnaise, right? That's 2 options here, mustard or mayonnaise. So 2 out of the 18, which would be 1 out of 9. Probability is 1/9 having ham and rye bread. I'll use this one for these here. You and a friend plan on going on 2 more rides at the amusement park before going home. You can choose from Amazing Falls, that's one of them. Tiger Canyon, that's another. Whenever there's a list of stuff, especially with words, I like to circle each thing so I can count up how many there are really quickly. Avalanche, Glacier Mountain, Indy 5, Bear Cave, and the Bat. Your friend decides to write the names of the rides 2 times, that's important, on each pieces of paper and place them in a hat. You each randomly select a ride without replacing your choice in the hat. So there's 1, 2, 3, 4, 5, 6, 7 rides times 2, 14 total rides. Well, 7 rides, and then you each put it in twice. What if we both select Bear Cave? Well, if I select Bear Cave, there's a 2 out of 14 chance that I select Bear Cave. And as it said, without replacing, then my friend picks, there's only 13 choices left and only 1 Bear Cave little piece of paper left. So do some simple math here. I can actually do some reducing here if I want to do that. And it becomes 1 out of 91. 1 out of 91 chance that you're both going to pick Bear Cave. 17, determine if this is independent or dependent event and also choose the correct explanation. Hence, you'll choose 2 bubbles. So, like on your test, you'll have a similar question. You have to choose either dependent or independent, and then choose one of these 4 reasons. So, is this, 17 is talking about number 16, is number 16 there dependent or independent? Well, independent means that one thing does not affect the other. Dependent means that one thing does affect the other. These are dependents for the very simple fact of, we took one out and didn't replace it. So whatever we pick the first time will affect the second time we pick. And then the reasoning will be, because they did not replace the hat. That looks pretty good. Let's read all the answers though. Because they wrote each ride twice, that's not it. Because there were 2 people picking, nope, not it. Because they did replace the ride. Well, they didn't replace the ride. It says right there they did without replacement. So B and C is what you would choose. 18, weather forecast states that there's a 50% chance of rain on Thursday and 40% on Friday. So we got Thursday and we got Friday. We got a probability for that and a probability for that. We're trying to figure out the probability of it raining on both Thursday and Friday. Probability of raining on Thursday is 50%, right? 50 out of 100. Always should use fractions. And Friday is a 40% out of 100. Multiply these together, we get, I'll do some simplifying here first. 20 out of 100, 2/10 or 1/5 chance. Or 20% if you really wanted to put it in a percent. Either one's fine. That is about it. Hopefully you do some studying tonight.